Identification of sides in a right triangle. Welcome, everyone. Today, we are beginning our journey into trigonometry. Before we can dive into complex calculations, we must master the most fundamental step, the ability to correctly identify the sides of a right-angled triangle. Now, what exactly is a right-angled triangle? Simply put, it is a triangle where one of the internal angles is exactly 90 degrees. As we move through this lesson, you'll notice something very important. The names we give to the sides of the triangle are not fixed or permanent. Instead, these names depend entirely on which acute angle we choose to focus on. This might seem like a small detail, but it is a critical concept to grasp right now. Why? Because all the trigonometric ratios we are going to study later, things like sine, cosine, and tangent, are based entirely on how accurately you can make these identifications. So, let's make sure we get this right from the very start. Step 1. Identifying the hypotenuse. The good news is that the hypotenuse is actually the easiest side to identify. Unlike the other sides we will discuss later, its position never changes, regardless of which acute angle you are considering. To identify it, you just need to remember two things. First, by definition, the hypotenuse is always the longest side of a right-angled triangle. Second, you can always find its location by looking directly across from the right angle, which is the 90-degree angle. Let's look at an example to make this clear. Imagine we have a triangle, delta ABC. If the angle at vertex B is 90 degrees, then the side directly opposite to it is side AC. Therefore, side AC is our hypotenuse. This side will remain the hypotenuse no matter which of the other two angles we choose to focus on in the next steps. Now that we understand that the names of the sides depend on our focus, let's start with the best place to begin. Step 1. Identifying the hypotenuse. Step 2. Choosing a reference angle. Now that we have successfully identified the hypotenuse, which, as we just learned, is the fixed, longest side opposite the right angle, we need to address the remaining two sides. Here is the crucial part. Unlike the hypotenuse, the names of these other two sides are not permanent. Before we can label them as opposite or adjacent, we must first make a choice. We need to pick one of the two acute angles in the triangle to act as our reference angle. Think of this as choosing our point of view. For the sake of this demonstration, let us assume we are focusing our attention on angle A. Once we have fixed our eyes on angle A, the identities of the remaining sides will be determined based on that specific position. Step 3. Identifying the side opposite to the angle. Now that we have moved on from identifying the hypotenuse and have successfully picked our reference angle, let's stick with angle A for this discussion. We can move on to step 3. Identifying the opposite side. By definition, the opposite side is the side that does not touch the vertex of our chosen reference angle. To make this easier to visualize, I want you to use a simple visual cue. Imagine you are standing right at the vertex of angle A, looking across the triangle. The side that you are looking directly at, the side that faces you from across the triangle, is your opposite side. Let's look at our specific example in triangle ABC. If we are focusing on angle A as our reference, the side that faces it, which is side BC, is the side opposite to angle A. Keep this in mind, because as we will see in the next slide, identifying this side correctly is the final piece of the puzzle before we identify the adjacent side. Step 4. Identifying the side adjacent to the angle. Now that we have identified the hypotenuse and the opposite side, we have one final side to name, the adjacent side. To define it clearly, the adjacent side is the side that is part of our chosen reference angle, but, and this is important, it is not the hypotenuse. If you are looking for a visual cue to help you identify it, think of it as the side that connects your reference angle directly to the right angle. It acts as the bridge between the two. Let's look at our example from the previous slides. In triangle ABC, where we have decided that angle A is our reference angle, we can see that side AB helps form angle A, and, as we already established, it is not the hypotenuse. Therefore, we can conclude that side B is the side adjacent to angle A. In the next slide, I will show you how this concept applies to a real-world scenario involving a ladder against a wall to help solidify this understanding. Real-world example, a ladder against a wall. Now that we have mastered the theoretical definitions of the sides, let's apply what we've learned to a real-world scenario to see how these labels work in practice. Imagine a ladder leaning against a vertical wall. If you look at the shape formed by the ladder, the wall, and the ground, you'll see they form a perfect right-angled triangle. Let's break down this scenario. The ladder represents the slanted part of our triangle, the wall is our vertical part, and the ground is our horizontal part. To make our identification process precise, let's designate the angle formed where the ladder meets the ground as theta. Now let's go through our step-by-step identification process, just like we did in the previous slides. First, let's identify the hypotenuse. Remember, the hypotenuse is always the longest side and is always opposite the 90-degree angle. In this case, the right angle is located where the wall meets the ground. The side directly across from that corner is the ladder itself. Therefore, the ladder is our hypotenuse. Second, let's identify the opposite side. To do this, we must look from our chosen reference angle, which is theta. If you were standing at the base of the ladder at angle theta and looked straight across the triangle, the side you would be facing is the wall. Thus, the wall is the side opposite to theta. Finally, let's identify the adjacent side. The adjacent side is the side that helps form our reference angle but is not the hypotenuse. Looking at our angle theta, it is formed by the ladder and the ground. Since we already identified the ladder as the hypotenuse, the remaining side, the ground, must be our adjacent side. So, the ground is the side adjacent to theta. As we will see in the next slide, it is important to remember that if we were to move our focus to the angle at the top of the ladder, these roles would change entirely. The concept of swapping roles. Now, this brings us to one of the most important points in this entire lesson, and I want you to pay close attention here. It is absolutely vital to understand that the labels opposite and adjacent are not permanent. They change whenever you change your reference angle. Let's look at our triangle ABC, where angle B is equal to 90 degrees. First, let's go back to what we practiced in the previous slides. If we decide that our reference angle is angle A, then, as we've already identified, the opposite side is side BC, and the adjacent side is side AB. But here is the twist. What happens if we shift our focus? If we choose angle C to be our new reference angle, the roles swap. Now, the opposite side becomes side AB, and the adjacent side becomes side BC. Now, don't let that confuse you. Notice that one thing stayed exactly the same. The hypotenuse, which is side AC, remains the same in both cases. It never moves because it is always anchored opposite that 90-degree angle. As we move to the next slide, we will look at some common pitfalls to ensure you don't get tripped up when these labels start swapping around. Common mistakes to avoid. Now that we have covered the steps for identifying the sides and seen how they apply to a real-world scenario like a ladder against a wall, I want to pause and highlight some common pitfalls. As you begin practicing these problems, please be mindful of these 3 common mistakes to ensure your foundation in trigonometry remains solid. First, a very frequent error is assuming that the bottom or horizontal side of a triangle is always the adjacent side. It is easy to fall into the habit of thinking this way, but it is incorrect. Remember what we discussed in slide 3 regarding the reference angle. The labels depend entirely on your perspective. If you choose a very reference angle located at the top of the triangle, the vertical side actually becomes your adjacent side. Always look at your chosen angle before labeling. Second, please be careful not to confuse the hypotenuse with the opposite side. These two are distinct. As we learned in slide 2, the hypotenuse is fixed. It is always the longest side and is always located directly across from the 90-degree angle. The opposite side, however, is relative. It is the side facing your specific, chosen acute angle. Don't let these 2 definitions overlap in your mind. Finally, the most important rule is, do not forget to pick a reference angle first. You cannot accurately name a side as opposite or adjacent in a vacuum. Before you start labeling any sides, you must decide whether you are focusing on angle A or angle C. Without that decision, the terms opposite and adjacent simply have no meaning. Once you avoid these mistakes, you will be perfectly prepared to move on to our final summary of the key takeaways. Key takeaways. First, let's revisit the hypotenuse. Remember, this is your anchor. It is always the longest side of the triangle, and its position is fixed because it is always located directly opposite the 90-degree angle. No matter which angle you choose to focus on, the hypotenuse stays the same. Next, let's look at the opposite side. Unlike the hypotenuse, this side is relative. It is the side that faces your chosen reference angle. A great way to remember this is that the opposite side is the one that does not touch the vertex of your reference angle. Then, we have the adjacent side. This is the side that helps form your reference angle along with the hypotenuse. It is the side that connects your reference angle to the right angle. Finally, the most important concept to keep in mind is relativity. Always remember that the labels opposite and adjacent are not permanent. As we saw in our examples, if you swap your focus from one acute angle to the other, these two sides will swap roles. All right, we have reached the end of our lesson. Let's take a moment to recap everything we have covered today to ensure these fundamental concepts are clear in your mind. If you have mastered these identifications, you are now perfectly prepared to move on to our next topic, calculating trigonometric ratios. Well done.